So this one here, when we set up the function, so the function is y equals 1 over x. So I want to point at x equals 1, y equals 1. So that black dot there represents x equals 1, y equals 1. And I'm going to choose a point arbitrarily close to 1, which is going to be 1 plus h. And so the y value of that function is going to be 1 over 1 plus h. Okay, so here's my ratio. It's going to be 1 plus h minus 1, so the red minus the 1, and then it's going to be the 1 plus h minus 1, so that's going to be my rise and run. Okay, so right now I have 1 minus 1 over 0, so 0 over 0. I have to get rid of that divide by h. Now to get rid of the divide by h, we need to get a common denominator here. So I'm going to end up with 1 over 1 plus h minus 1 over 1 plus h over 1 plus h. So that's going to be 1, all divided by h. So getting my common denominator, I'm going to end up with 1 plus h minus, so it's going to be 1 on this side, minus 1 plus h. So I'm going to be left with negative h over the common denominator, and dividing by h, I'm just going to put in the denominator is divide by h like that. So when my 1's cancel out, I end up with a factor of h. That's what I wanted, because I know now that that negative h is a factor, and those h's can now cancel out. So canceling those h's out, I'm left with negative 1 over 1 plus h. Well, the h in the denominator there, this h here is not a problem, because if I let that be 0, I don't have 0 in the denominator. So just cleaning that up, I'm going to end up with negative 1 over 1 plus h. That's going to end up with a slope of negative 1. And if you look at that graph, okay, yeah, that if you actually look at the actual graph, and even the graph that I've sketched, you can see that that point is going to have a slope of negative 1, or negative 45-degree slope there. Okay, so there's my instantaneous slope at that point. So this one here is going to be looking at the slope at x equals 3 on this square root function. Okay, so first of all, I'm going to draw my square root function. Okay, at x equals 3, y is equal to root 3. Okay, so there's my point. I'm going to select some arbitrary point close to it. I'm going to call that 3 plus h. And so the y coordinate of that is going to be square root of 3 plus h. Okay, so there's my rise and run. Okay, there's my run. That's going to be h. Okay, and the rise is going to be the difference between those two coordinates. And I need to set this up with a limit, because I'm going to end up dividing by 0. So limit as h goes to 0, it's going to be square root of 3 plus h minus square root of 3 all over h. Okay, so this is a special one, and we just have to figure out how am I going to get rid of that divide by h. I need a factor of h here, which means I need to get rid of the square roots here. Okay, otherwise I don't have, and the minus as well, because I need to get rid of, I need to be able to free up a factor of h to cancel with that h. So to do this, we need to use conjugates. Okay, so we've seen this before. If I have a square root minus a square root, and I multiply by its conjugate of a square root plus square root, and if I do that on top and bottom, I don't change the ratio. If I do that, this is a difference of squares, so I'm going to end up with a squared minus squared, which then allows me to get rid of the square roots. Okay, so that's kind of the main issue. We'll see what happens from there. So I'm going to end up with 3 plus h minus 3, so squared minus squared, and h times root 3 plus h plus square root 3. Okay, well, this is perfect, because I now can get rid of the plus 3 minus 3. I've freed up a factor of h, which now will simplify with that cancel out with that divide by 0 that I had before. So now I've gotten rid of the 0 over 0, and this h here is not a problem because of that plus, I'm not going to generate a 0 in the denominator. So working this through, just cancel out that h, divide h, okay, and then writing the limit as h goes to 0, that's going to end up being 1 over 3 plus h plus root 3. Well, that's going to simplify to 2 root 3. It's going to be root 3 plus root 3. There's the slope at that point. So my tangent slope at that point, that's going to have a slope of 1 over 2 root 3. Okay, and I used the limiting process to get that.